Guys, today we talk about the rigid body. We need to go to the effects to go to the rigid body. Fields. You can see over here there's a two type of rigid body. One is a active, another is a passive. So what is rigid bodies? Rigid bodies are act like a real-time mouse objects, a real-life simulation. Suppose if you drop the box from the first floor, it will go and hit the ground and it will react accordingly. Suppose if you throw the ball, it will react accordingly according to the mass and then the attitude of the thing. Here, active rigid body which is moving, passive rigid body which is not moving. Example, if you're throwing the box from the top to bottom, which is not moving is a ground. Ground is a passive, which go and hit and it will bounce is a box. It's a active rigid body. Same way, if you throw the ball to the wall is static, so it is a passive rigid body. The ball is moving, so it is an active rigid body. Now let's go to set the scene. This is the ground, and this is the box. Yeah, we'll move a little bit like this and play. There is no animation, isn't it? So this animation is going to be happen automatically. It is called a simulation. Select this, click the passive rigid body because it is not moving. It's a ground. Now nothing will happen because you need to give the active rigid body. To click the active rigid body, you can do also apply any field. Once you apply the field, the particular object is become an active rigid body. So gravity is a common thing for everything. Just click it, go back and play now. So the simulation happening well in the attribute editor. Select this box and you can see the rigid body. In the rigid body, you can see the first one is called a mass and go down. There is a few interesting options like a bouncing, damping, impulse, friction. To change this attribute, we can change the attitude of the box. Now, look at the bounce. It's a 0.6. Suppose if you put one bounce, got it? If you increase the friction, it won't move much. Damping, slowing. So these attributes will change the attitude of the box. How weight, bounce, damp, and friction. This should be. Impulse is a push on particular direction. Okay, this is the x-axis. We'll put the push on the x-axis 1. So it will automatically go to the x-axis. Can you see? It will go towards the x-axis. Maybe I'll put very less, 0.2. So it will move, not much. You can increase the timing. Okay, it will react with the passive rigid body. Suppose if it is ends, it will go down. It's need a mesh to react. We create another mesh. Okay, this is another mesh, a small one. But this mesh is not active or passive. What happened now? You can see It's overlapping because it's just a mesh. It's a normal mesh. It is not converted as a rigid body, either active or passive. We are not converted as a rigid body. Okay, how do you convert? Just click the rigid body. But once you click the active rigid body, this has become active rigid body. It can contact, but the problem is it doesn't have any fields. Okay, let me do that. Active rigid body. Now we can see this. It's reacting, but it's just going up like a balloon because it doesn't have any fields. So select this, apply the field. Gravity is important field for everything. You know. Now I'll give you an exercise. You can see this setup. Snowboarding. And I'm creating this as a active rigid body by using the gravity. And then make sure the impulse towards z-axis, 0.5. And this is a passive and this is the passive rigid body. And all this should have a gravity. Okay. So once you create the gravity, you can see it will go and settle to the ground properly. Yes. Now the impulse is created, so this should come towards this axis. Okay, now the collision should happen. Okay, the timing need to increase 200, maybe 500 also is fine. 500, 700 is fine. Okay, this is the passive, so it is not allowing the ball to go outside of it. This is the passive, it is not going to allow the ball to stop. So this is a simple setup to understand rigid bodies. It will create the real-time simulation. This particular has constraints. You already know point constraint, aim constraint. Those are all animation constraint. But this constraint is for rigid body constraint. The first constraint is, first I'll create the rigid body by clicking the gravity, selecting this. First is a nail constraint. It is like nail the object. But the only thing is the nail constraint you can see the left side should not be in a same place. Maybe I'll move this nail constraint over here. Now you play. Yeah, that is the nail. Nail constraint is activated. Next is a pin constraint. For that, you have to select the two objects to pin. Okay. Now this is a rigid body, active rigid body, but this doesn't have any field. It means especially the gravity. Now you can see this. This is not reacting with the gravity. So you have to click the gravity. Now okay, I'll give you a more time. Here, go to the rigid body of this, the mass, the weight. Click the increase the weight of this one. You can see the flow. That's what we call as a real-time simulation. Increase the mass. Mass is a weight. Okay. So this is the pin constraint. We'll talk about the mass again. This pin constraint, I'll give you another situation. It's a chain. Mhm. Control D. The another important factor is the meshes should not collide each other. The mesh should not collide. It means intersect. So decreasing the radius. In initial stage, if the mesh collide, the active and passive rigid bodies become same. So it should not collide. Creating the chain. Select these two and click the pin constraint. Same way to others. But okay, I'll try one more option also. So duplicate flow. All the things should be in a gravity. The first one should have the nail constraint so that it will stick over here. Play. Yeah. Because of the, see, it's broke. But actually the concept is correct. Anyway, I'll try with the pin constraint. This two pin, this two, this two. Using the G command, recently used command, it's called G. Then pin constraint, sorry, a nail constraint for this. Play. What happened? We are not giving assigning any gravity to the object. Select everything. Gravity. Play. Okay. The simulation is taking much time, so I'll delete these things. Now play. Timing. So Dynamics will create the real-time simulation. This is a pin constraint. So I can try like this. The next is a spring constraint. First create the gravity for this, then the spring constraint. It's like a rubber band. It is exactly like a rubber band. It's like a spring. That's it. The next one is hinge constraint. It's used for rotation. Hinge constraint. Wherever the hinge is there, the rotation will happen according to the hinge position. Okay, I'll put it in the center. Let it be in the center. Now we'll create a Okay, two things. Gravity. Now it will go and hit on the Caesar. Because of the hinge is in the center. Now you can select the hinge, move it to the left. You can see the difference now. Next is a barrier constraint. Suppose if you don't want to go beyond the particular limit, you can do the barrier constraint. You don't want to move beyond this point. That's it. This is a barrier constraint. It will stop this time. But it will stop only on the y-axis, not in a x or z-axis. You can create barrier constraint for any objects so that it will go and stop. Only according to the pivot point, the barrier will work. Object pivot will stop on exact on the barrier limit. So this is called rigid bodies. I hope you like it. You do the chain exercise and try to practice more on the constraints. And the next one is called cloth. Already you know that. Let me do the cloth now. For the cloth, we need a very good segments because of the fold. So this is the end cloth, and whatever it is, it's called a passive collider. And this is end cloth const. That's it. Display. Suppose if you rotate something like this, now you can see simulations play. Okay, sometimes we cannot able to play this one because of the simulations taking much RAM, so that we can do a cache. This cache file will store the simulation. Say an example, I play in forward, it's moving. So if I play backward, is it moving? Can you see this? This is the end cache. You can see this one down here. Now I'll change the position for this. Play. Stop. You can see this one is creating the, yeah. Okay, now how to store this one? How to store the end cache? Over here, you can see this cache, create new cache, and object cache. Click it. Okay, if you have saved the cache already, it'll ask you, do you want to save again? Yes, auto rename or replace the existing. I replace this existing. What is the difference between this end cache and simulation? Simulation will change according to the position of our interactive objects. Now, okay, I move this one. I move this one. Play now. How it is interacting? Because in cache is store the simulation in the permanent memory. Permanent memory. Simulations will create according to the RAM, but Encatch will create or it will go and store on the permanent memory. Okay. Suppose you are changing over from here to here and playing, but still the cache showing the previous saved one. How to rework on it? Encatch, you can say that create new cache again or replace the cache or append to the new cache. So creating the cache is very simple way to get the real simulation to store on your system. So that it is this one is going to be a final. Okay, this also having the constraints. This having the constraints. The first constraint is point to object constraint, point to surface constraint. This constraint is very interesting. Now we'll create an example for the constraint. So always make sure that division is high. We're creating the flag. Point to surface. First create the end cloth. Create a end cloth and select these vertices. Select the object constraint. I'm sorry, end cloth, point to surface. Now play. Yes. Now we need a wind. It's very simple. Select this end cloth, go to the attribute editor and check the end cloth attributes. Here you can see end cloths, yeah, dynamic properties. You have the dynamic restrictions. Here, okay, the mouse, less mouse. You can change the attitude of this one. And very importantly, go to the presets and you can change the presets like silk or whatever you need. Attitude of the cloths can be changed by using the end cloth shape presets. So you'll get a strong understanding when you change these presets, the attributes will change. Accordingly, you can understand the attitude of the cloth. Now, to enable the dynamic attributes, you need to go to the nucleus. Nucleus is a solver for this enclosure. This is the nucleus. It will have the gravity, air density, and other things. But I need an air speed. Air speed like 0.5 is enough. On which axis? It says the x-axis. I think x-axis is correct. Wind speed increased to 2, maybe 5. Okay, stop and play now. Okay, my RAM is very slow today. So I go to the end catch, end object, replace existing. Okay, I think the 5 is less. I'll make go to the nucleus, 8, again, end catch, end catch. Beautiful. So this is the direction. You can change the any directions. You know how to apply the textures, and then you know how to do the render. So you can apply the cloth, can apply the any flag texture, then put the lighting and take a render. That's it. So only thing is you need to understand the attributes of the selected objects, even rigid body or end cloth or nucleus. Okay, guys, please enjoy the rigid bodies and cloth.